Hello, so this is Mrs. Hickman, and today we're going to be talking about motion along the line. Okay, so that's projectile motion, and when a particle is moving forward and backward and right and left and increasing and decreasing, which would be, so let's get started. So, motion along the line. So suppose that an object is moving along a coordinate line, say an s-axis, so that we know its position s on that line as a function of time is t. So we know here that s is going to be our distance, okay, and then we have a function of t. So when we make a graph, we're going to have t here and s here. So s is our distance, t is our time. Displacement. So if you're taking physics right now, you know displacement is a vector quantity that depends on magnitude and direction. For example, if I went from here to here, so I went here to here and then back again, my displacement would be 0 because you're adding your distance here and then you're subtracting, so it ends up 0. So that's what displacement is. So change in s is going to be just your final minus initial value, which is shown here. So this is going to be a t plus a change in t, so this is going to be the final t value minus the initial t value. That's all that says right here. Okay, so average velocity. Okay, average velocity of the object over the same time interval is this. So you have change in s over change in t minus, so that's going to be s final displacement minus initial displacement over final time minus initial time. Okay? And then you have this equation, which pretty much says the same thing. This is your final time, t plus change t minus the original t over change in t. So, is this a secant line or a tangent line? Well, the answer to this question is going to be a secant line. For example, so these are 2 points. You have S1 and T1, T1 and S1, and then you have T2 and S2. So if you were making a graph like that, here's the first point, there's the second point, your line is going like that, and that's a secant line. A tangent line is at a point right here. Instantaneous velocity, so all this should be review material for you, of an object at an exact instant time is a derivative of the position function with respect to time. So great, so now we know the derivative of the position function is going to be velocity. And here is that awesome definition of a derivative right here. But no worries, we're not using that, that's just for your understanding. So all this change in t as it approaches 0, that means A and B is getting closer and closer and closer and closer together. So that pretty much is it, your distance between A and B is 0. So that's all that means right there. Speed is the absolute value of the velocity, which just means all your negative values will become positive. For example, if you had a graph that looks like this, okay, your speed graph is going to look like this. You go up, up, your speed graph will look like this. So whatever is negative, just make it positive. Okay, that is your absolute value graph right here. Okay, oops, I was supposed to be good. Alright, so next we're going to be doing acceleration. So acceleration is going to be the derivative of velocity with respect to time, and consequently that's going to be the second derivative of the position function. Okay, so derivative of velocity, second derivative of position. And so here you go, if those dv's over dt's and d squared s over dt squared is giving you a headache, you could also write it just like this, okay? So st, this corresponds to the original function, or we can call that position. Okay? The first derivative of the position function is velocity. the second derivative of position or the first derivative of velocity is going to be the acceleration function. So, okay, so that's easy enough. So let's just make it a little bit more difficult, shall we? Because we are in calculus. Who knows difficulty without calculus? Okay, not you, because calculus is easy for you. Keep on going. Okay, so reading motion on the graph. If S of t is positive, so if this is above this axis, it's moving forward. If this is negative or it's below here, your object is moving backwards. If it's 0, depending on what, it's changing direction if it's just like crossing the axis, and it's still if it's just kind of like on the line right there. So that's how that works, okay? Which makes sense because we have positive displacement values this way. So if we cross, we're going, okay, so we're going. And then we're just going to add to this graph because I can. Down here. So we're going positive and they're like, never mind, we want to go the other way. Okay, so that's what happens there. You're changing direction. And if you come up here again and then you just kind of sit there like that, that's when you're being still. Okay, because we're not stopping the clock, the time is still going. So if you stand somewhere long enough, you're standing still for a time interval. Okay? So now we're going to relate the position function and the velocity function. So we're going to be looking at making, if you were given the position function and you want to know what velocity would be doing, this is how you would make it. Okay? So if the slope of the position function is positive, then your velocity has positive values and it's going to the right, okay? So here's the velocity. So right here, if it's positive, so if I have a positive slope, this tells me the object is moving to the right. And then if it's negative, if I have a negative slope, object is moving to the left. And then if it's 0, that's when that is when the object is changing direction. Okay? Alright, so velocity graph. So relating objects' displacement and velocity. So, if velocity is greater than 0, the object is moving forward. If the velocity is down here, the object is moving backward. And if the velocity is 0, it's still or it's changing direction. Okay? Relating objects' velocity and speed, greatest speed is going to be the highest and lowest values. Okay, so we kind of already went over that. Okay, speeding up and slowing down, we're going to see acceleration, which we're going to get to. Relating velocity and acceleration. So a positive slope, the acceleration is going to have positive values. A negative slope, your acceleration is going to have negative values. And a 0 slope, your acceleration is going to be crossing the t-axis. Okay, so here is the acceleration. Okay, and that's the same, this is the slope of this velocity over here. Okay, so you see velocity is positive slope, so acceleration is going to be on the positive axis from 0 to 5. So you see it that way from 0 to 5. And then your slope is 0 because velocity is constant. So if velocity is constant here, acceleration is going to drop down here. And then you have a negative slope. So you're going to have here, down here, and then you're going to be somewhere down here depending on what that negative slope is right there. And then you're going to go positive slope. Okay, so speeding up and slowing down. Okay, First, note the t values when the velocity is 0 and when the slope changes. Under a number line, correspond a of t with the slope under the intervals where slope is positive, negative, or 0. Under a of t, depict when velocity is positive, negative, or 0 under the intervals. Okay, this will make sense later. Same sign, so this is what you need to know. So if you have the same sign, that means the particle is speeding up, whether it's positive, positive, negative, negative. Opposing signs mean the particle is slowing down. Okay, so let's do an example. Okay, so when is the particle moving forward, backward, still, or changing direction? So let's review. So this is the velocity graph, so we're going to go over here and see. So velocity graph. Right there. So if velocity is positive, if the velocity is positive, it's moving forward. If it's negative, it's moving backwards. If it's crossing, it's changing the direction, and if it's still, it's just going to kind of glide along the line. Okay, so let's write and see where velocity is positive. Just do a little number line here. So velocity is positive from 0 to 15. Okay. It's going to change direction here because it's going, so it's going to be positive. So it's changing direction right here at 15 because it's crossing. And then it's negative from 15 to about 27. Okay, and then it's going to stand still right here. So moving forward is going to be where velocity is positive, so it's going to be 0. To 15. Okay. Backward, it's going to be when velocity is negative, so that's going to be 15 to 27. Okay. Still is when it's crossing, so that's going to be at t equals 5 seconds. We'll soon. Well, that's, never mind, that's going to be when it's changing direction. And when it's still, that's when it's going to be from here. So 27 to about 31. Okay. So we'll have velocity is positive here. Negative. And positive. Okay, next line, when does the particle have its greatest speed? Well, speed is just absolute value of velocity. So let's look at our highest value. So here we have about 15 right here. But remember, speed is absolute value, so if I was drawing an absolute value graph of here, let me go over here because it's the same graph. Yes, same graph here. So the speed graph is going to look like this. You're just going to bring this up here to 15. Okay, so your speed is going to be, your greatest speed is going to be on this interval from 4 to about 7. And then at, so t equals 4 to 7 seconds. And t equals 24. Okay, so that's speed. Now particles acceleration. So now we're looking at slope. So every time the slope changes, we're going to make another interval. So we have from 0 to 4 is a positive slope. Okay, from 4 to 7, it's 0. And then about 7 to 15, it's a negative slope. Okay, so while I'm putting this in, you're going to see why velocity is positive from 0 to 15. Okay, and now we're going from 15 to about 23. 15 to 23, that's when something's changing, the slope's changing. To 23, so still negative. 23 to 27, velocity is negative, and acceleration is positive because you got a positive slope. And then from 27 on, velocity is 0, not positive. And acceleration is 0. So based on this, we're going to see when it's speeding up and slowing down. So speeding up is when the signs are the same. So it's going to be from 0 to 4 seconds and 15 to 23 seconds. And slowing down is going to be when the signs are opposite, so 7 to 15 and 23 to 27. So again, review. How you do this little interval table. You're first going to see where velocity is positive and velocity is negative and when it's changing direction or still. Okay? So velocity is positive from 0 to 15. That's when it's above the t-axis. It's changing direction at 15, so it turns from a positive to a negative here. And then it becomes 0 from 27 to 30. Now acceleration is about your slope. So that's positive here, 0 here, negative, negative, positive, 0. Okay? If you want to, you could also do this type thing. The green would be representing velocity. And you just look at where you have opposite signs and opposing signs, and of course that's when you're changing direction. Okay, so homework will be on 3.4, 9/11, and if you want to, you can talk to any of my students. Does any of my students want to say hello?
Hello.
Okay, here's Frank. Frank, where are you from?
I'm from Vietnam.
Okay, that's cool. Totus, you want to say hello? Okay, that's Totus. Totus, where are you from?
Lithuania.
Lithuania. Can you say hello, Lithuania?
Labas.
All right, cool. Can you say hello in Vietnam?
Xin chào.
All right. What about bye?
Chào.
Ciao. Okay.
At that.
All righty. Y'all have fun. Bye.